Our sun is having a tantrum. Right now, today, our star is in the most active phase of its 11-year cycle. Solar flares erupting, coronal mass ejections blasting billions of tons of plasma into space, auroras appearing at latitudes that haven't seen them in decades. And somewhere out there, around another star in another solar system, scientists are wondering if an advanced civilization is doing exactly what we're doing, watching their star, building technology, sending signals into the cosmos. Two of the most fascinating stories in modern space science, happening simultaneously, right now. Hey space family, welcome back to D3. Discover deep dreams, your educational gateway to the cosmos and beyond. I'm your co-captain, and today we are covering two extraordinary stories that together paint a picture of where humanity stands in the cosmos. Solar maximum, the peak of our sun's activity cycle, and what it means for Earth right now. And technosignatures, the cutting-edge science of searching for evidence of advanced civilizations beyond our solar system. Let's dig in. The sun is not a constant, steady ball of fire. It's a dynamic, churning, magnetically complex star that goes through cycles of activity roughly every 11 years. At solar minimum, the quiet phase, the sun's surface is relatively calm. Few sunspots, few flares, relatively quiet space weather. At solar maximum, the active phase, everything changes. Sunspots multiply across the solar surface. Solar flares erupt with increasing frequency and intensity. Coronal mass ejections, massive eruptions of solar plasma, blast out into the solar system. The sun becomes a restless, energetic, occasionally dangerous neighbor. We are currently at solar maximum, or very close to it, for solar cycle 25. And solar cycle 25 has been more active than scientists initially predicted. During solar maximum, the effects on Earth and near-Earth space are significant and wide-ranging. First, auroras. The increased solar activity drives more charged particles into Earth's magnetosphere, creating auroral displays at much lower latitudes than normal. During solar cycle 25, people as far south as Florida, Texas, and even parts of Mexico have witnessed northern lights that would normally only be visible in Alaska or northern Canada. If you have never seen the aurora, solar maximum is your best chance. Second, satellite drag. Earth's upper atmosphere expands slightly during solar maximum as it absorbs more energy from the sun. This expanded atmosphere creates additional drag on satellites in low Earth orbit, causing them to slow down and gradually lower their orbits. SpaceX has lost Starlink satellites to solar maximum-related atmospheric drag. Operators of low-orbit satellites have to work harder during solar maximum to maintain their positions. Third, radio blackouts. Intense solar flares can release X-rays that travel to Earth at the speed of light, arriving in just 8 minutes. When these X-rays hit Earth's ionosphere, they can cause radio blackouts, disrupting communications for aircraft, ships, emergency services, and military operations. Fourth, radiation hazards. Solar maximum increases the radiation environment in space, particularly relevant for astronauts aboard the ISS and for any crewed deep space missions. During solar cycle 25 solar maximum, mission planners have been particularly attentive to radiation monitoring for the Artemis II crew. Fifth, power grid risks. The most powerful solar storm, called X-class flares, followed by coronal mass ejections, can induce electrical currents in power transmission lines, potentially damaging transformers and causing widespread blackouts. The 1989 Quebec blackout, caused by a geomagnetic storm, left 6 million people without power for 9 hours. A Carrington-level event today could be catastrophic. Solar maximum presents particular challenges and opportunities for space exploration. The challenge: radiation. As we discussed in our cosmic radiation video, deep space is already a dangerous radiation environment. During solar maximum, solar energetic particle events, intense bursts of radiation from solar flares and CMEs, add an additional layer of danger. Mission planners have to account for the possibility of a major solar storm during any crewed deep space mission. The opportunity, science. Solar maximum is the best time to study the sun in its most active and dynamic state. Missions like the Parker Solar Probe, which has been flying closer to the sun than any spacecraft in history, are gathering unprecedented data during this active period. The Solar Orbiter mission is providing the first ever images of the sun's polar regions. And the SMILE mission we discussed earlier will be studying the effects of solar maximum on Earth's magnetosphere in real time. Solar maximum is challenging, but it's also one of the most scientifically productive periods in the solar cycle, and scientists are taking full advantage. Now, let's zoom out, way out, beyond our solar system, beyond our galaxy, into one of the most profound questions in all of science. Are we alone? For decades, the search for extraterrestrial intelligence, SETI, focused primarily on radio signals. The assumption was that if an advanced civilization wanted to communicate across interstellar distances, they would use radio waves, which travel at the speed of light and can cross vast cosmic distances. But in recent years, a new approach has emerged, one that doesn't require an alien civilization to be deliberately trying to contact us. Instead of looking for messages, scientists are looking for evidence, footprints, artifacts, signs that technology exists somewhere in the universe beyond Earth. These are called technosignatures. A technosignature is any measurable property or effect that provides scientific evidence of past or present technology. Just as biosignatures are chemical signs of biological life, oxygen, methane, water, technosignatures are physical signs of technological civilization. The range of potential technosignatures is extraordinary, and getting more creative as our detection technology improves. Industrial pollution. Here on Earth, our industrial civilization has filled our atmosphere with chemicals that wouldn't exist naturally. Chlorofluorocarbons, nitrogen dioxide, and other industrial byproducts. If an exoplanet's atmosphere contained similar chemicals in concentrations that couldn't be explained by natural processes, that would be a powerful technosignature. The James Webb Space Telescope is now sensitive enough to potentially detect industrial atmospheric pollutants on exoplanets. The search for alien pollution as evidence of alien civilization is now scientifically feasible. Artificial light. Our civilization lights up the night side of Earth so brilliantly that it's visible from space. Future telescopes may be able to detect the artificial light signatures of cities on exoplanets, particularly the specific spectral signatures of LED lighting or other artificial light sources that wouldn't occur naturally. Megastructures. The most dramatic proposed technosignature is the Dyson Sphere, a hypothetical megastructure built by an advanced civilization around its star to capture the majority of the star's energy output. A star partially or completely surrounded by a Dyson sphere would have an unusual infrared signature, emitting more heat than light. Scientists have actually identified several candidate stars with unusual infrared signatures, including the famous Tabby's star, though natural explanations are always considered first. Laser signals. Some advanced civilizations might use powerful lasers rather than radio waves to communicate. Optical SETI, searching for laser pulses from distant stars, has become an increasingly active field. Unlike radio signals, which spread out in all directions, a laser can carry an enormous amount of information in a very narrow beam, making it potentially more efficient for interstellar communication. Heat signatures. Any advanced civilization that uses energy at a large scale must release waste heat. The laws of thermodynamics are universal. A civilization that has colonized an entire galaxy would produce detectable amounts of waste heat, observable as unusual infrared signatures at galactic scales. Here's the beautiful connection between these two topics. Our sun's solar maximum activity, our star-throwing solar flares and coronal mass ejections, is itself a kind of natural technosignature test. When our sun produces a powerful flare, It creates detectable signals across multiple wavelengths: radio, X-ray, optical, and more. If an alien astronomer with a sufficiently powerful telescope were observing our solar system from another star system, they might detect these solar signals. And if they were looking carefully, they might also notice something unusual about the third planet from our sun. Artificial radio signals leaking into space, city lights on the night side, industrial chemicals in the atmosphere, a civilization, our civilization, leaving its technological fingerprints across the electromagnetic spectrum. We are already a technosignature, and somewhere out there, around another star in another solar system, scientists are wondering if the signals they're detecting are natural or artificial, wondering if they're alone. We are asking the same question about them, simultaneously, across the cosmos. Our sun is at solar maximum, throwing light and energy and charged particles across the solar system in its most active and dynamic phase. It's beautiful, it's dangerous, it's the natural rhythm of our star, a rhythm that has shaped Earth's history for billions of years. And somewhere out there, in the vast, star-filled cosmos, scientists are listening, watching, and searching for the one signal that would change everything. The signal that says, we are not alone. That somewhere around another star, another civilization looked up at their sky and wondered the same things we wonder. We are searching, we are listening, and we are not giving up. That's what makes us human. And that's why we keep looking up. If you like space exploration, don't forget to like, subscribe, and ring that notification bell so you never miss a single D3 episode. Keep looking up.